Here we're going to understand the word solution of a quadratic equation. The meaning of a solution is these are value or values of x, which gives a true statement. I give an example. Solution of x square plus 5x plus 6 is equal to 0 are minus 2 and minus 3. So let's verify this. For that, we need to substitute x is equal to minus 2. So what will you end up with? Minus 2 the whole square plus 5 times of minus 2 plus 6 is equal to 0. So 4 minus 10 plus 6 is equal to 0. 10 minus 10 is 0. It's a true statement. So x is equal to minus 3. Minus 3 the whole square plus 5 times of minus 3 plus 6 is equal to 0. 9 minus 15 plus 6 is equal to 0. This 2 is a true statement. 15 minus 15 is 0. So these two values are said to be true statements. So do all the values, I mean, whatever you substitute, it can become a true statement, is it not? I mean, is it so, or is it just an exceptional values? Are these two values exceptional to this, or I mean, so can other values also be zeros of a given quadratic equation, some random values? So I've taken two random values, plus 1 and minus 1. Let's see if they do our solution of this. So for that, we need to substitute x is equal to 1. So we have 1 square plus 5 into 1 plus 6 is equal to 0. This is a positive value, this is 0. This is the false statement. Next, sub x is equal to minus 1 square plus 5 into minus 1 plus 6. So this is 1 plus 6, 7. 7 minus 5. It's a false statement. 2 is equal to 0 is a false statement. So solutions have another name, roots. Okay. So roots of x square plus 5x plus 0 is equal to, plus 6 is equal to 0 are minus 2 and minus 3. How do you represent roots? With alpha and beta. So is there a gamma over here or just alpha and beta? If you have come across the chapter quadratic equation, we have seen that degree is equal to 2, right? If the degree is equal to 2 of a quadratic expression, of a quadratic expression, degree by default is equal to 2. There the roots, zeros are, maximum zeros are 2. Here too the maximum roots are 2, and so we just represent with alpha and beta. How does it look graphically? So for that, we will enter our coefficients 1, 5 and the constant 6 and see what we get. So we have 1, 5 and 6. So nature of roots, we're talking about something that will come in the future of the topic. Roots are minus 2 and minus 3. Yes, we saw that. Those two values we do satisfy the equation. So we can clearly see the line is crossing minus 3 and minus 2. Right, this is your equation. I've typed in as linear equation. It's not linear. It says quadratic equation, right? Anyways, so we can see that the graph is crossing the x-axis at minus 3 and minus 2. So we can tell that the roots of this particular equation are minus 2 and minus 3. So graphically, what does it mean? It's the coordinate along the x-axis which the graph crosses. So graphical meaning is nothing but whatever expressions you have, the equation you have, if you plot it If you see that it's crossing particular values of the x-axis, particular coordinates of the x-axis, those are your zeros or roots or solution. In the next video, we'll look at checking out few values if they are solution of a given equations or not.